Hello guys, my name is Shankar Pense and you are all welcome to my YouTube channel. So guys, today in this video we will learn something called as random forest. As I have talked about bagging technique in my earlier video, so random forest is a type of bagging algorithm. Okay, so first of all, to start with, this is one of the ensemble learning algorithms. Okay, ensemble learning, and within ensemble this comes under the category of bagging. So I have already released a video on what bagging is. So just to repeat it quickly, this is also called as bootstrap aggregation. Okay, bootstrap aggregation. So I have explained this thing in detail in my bagging video. So if you haven't watched it, please go back and watch that video. Okay. So now coming to random forest. So what is random forest? You guys would have already guessed it because of the name forest. We will have multiple trees, right? And what are these trees? These will be decision trees. Okay, and why the name random? You would understand it in a while. Okay, so what happens in any bagging technique? Let's say we have the data set D and it has m rows and n features. Okay, so basically what I'm trying to say is we have the data set which looks something like this. We have features x1, x2, x3 up to xn and the target variable y. Okay, and we have m rows. Okay, so this is how our data set looks like, and let us represent this as capital D. So what happens in the first step? Okay, in random forest. So we take this data set D and we will create the subsets D1, D2, D3. Let's say we create k subsets from this particular data D. And how do we create these subsets? We use something called as row sampling plus feature sampling, right? To create each of these data set, we will use row sampling and feature sampling. So I'm just writing it in short, RS and FS. RS stands for row sampling, FS stands for feature sampling. And how this sampling is performed? This sampling is sample with replacement. Okay, sample with replacement. So this is what actually bootstrapping is, right? So while I was explaining bagging concept, I told you that we will sample the rows. I haven't talked about sampling the features there, right? But in random forest, what happens? To create the subsets of the data, we will also randomly sample the features as well with replacement. So what do I mean by random sampling with replacements on the features? So let's say we have n features, x1, x2, x3 up to xn. So if we are sampling these features with replacement at random, so let's say in the first data set D1, we may get features x1, x3, x20 and xn minus 1. Okay, and in D2, in the second subset of the data D2, we may get features such as x1, x2, x3 and xn. Okay, it's possible. It will be completely random, right? So in D3, we may get x1, x2, x3, x13, xn minus 2. So we will get some set of features, subset of features from the original data set D. Okay, along with the features, we will also do row sampling. So you guys already know what row sampling is, correct? So row sampling is similar to instead of features, we will sample the records, which all rows we need to consider for creating the subsets of the data. So by following these methods, we will create these particular data subsets. Okay, so let me clearly draw that. So what we do, we will have the data set, entire data set represented as D. Okay, so let us represent it as D here. So D, and then we will create the multiple subsets of the data D1, D2, D3 and up to Dk, right? So how do we do this? We will make use of row sampling and feature sampling. So once we are done creating multiple subsets of the data like this, next what is the task? So it's same as I explained in my bagging video, right? So what we do, we will fit our base models here. Model 1, model 2, model 3, model K, right? And since we are dealing with random forest, these base models would be decision trees. All these base models would be decision trees. So I'll call it a DT1, decision tree 1, DT2, decision tree 2, DT3, and so on and so forth up to DTK. Okay. Then what we do? We train these models on this subset of the data, row sampled and feature sampled subset data, and then we will get the outputs from each of the model. Okay. So this is same thing what I have explained in bagging. Okay. So this will be output K. So now the final output, we need to club these outputs. So this is called as aggregation step. Okay. And till this point, it is called as bootstrapping. Okay. So when it comes to aggregation, the final output actually depends on the task at hand. So if it is classification, the final output would be based on majority voting. And if it's on regression, it could be mean or median. Okay. So now what is majority voting? So let's say we are dealing with a binary classification task to predict the classes either 0 or 1. Okay. So what we do, we train this particular model which is called as random forest, and then we take the outputs from each of the sub decision trees within it. Okay. So let's say this model 1, the decision tree 1 outputs the class to be 0 for one row of data. So let's say we are considering this particular record here. Okay. So how do we predict? How do we arrive at the final prediction? So let's say for this particular record, decision tree 1 will predict class 0, decision tree 2 will predict class 0, decision tree 3 will predict class 0, and in between let's say one or two models predicts 1, and also the final model, that is model K, will also predict 0. So in this case, since it's a classification problem, the final output will be majority voting. So what is majority voting? It is the total, the maximum number of similar outputs from the sub models in the random forest. Okay. So what do I mean by that? So it is nothing but if maximum number of decision trees are predicting the class to be 0, the final prediction will be 0. Okay. If maximum number of decision trees in this particular model is predicting the class as 1, the final output would be 1. So this is called as majority voting, and this is how we arrive at the final prediction. But when it comes to regression, so this model will output some continuous value. This model will also produce some continuous value as an output. So each of these sub models, sub decision trees will produce some continuous value as the output. So in this case, what will be the final prediction? So what we can do, we can go ahead and take the average of all the continuous values. Average value of all models prediction. All models is prediction. So we can go with this, or what we can do before actually deciding whether to predict the average or median value, what we can do, we can take the output of each of the model, check the distribution. Okay. Check the distribution. If the distribution tells you that we have outliers in the output, or the outputs are varying very largely, we can go with the median as our final output. Okay, so that's it about random forest. This is how random forest works, and why it is called as random, because we are randomly sampling the rows and creating decision trees out of those randomly sampled rows and features. So all these decision trees are completely random. So that's why the name random forest. Okay, so if you have understood the bagging concept, it's very simple. There are one or two concepts to understand: what is bagging, what is a sampling with replacement, and then what is aggregation. That's it. So now coming to the intricacies of the random forest model. So since the submodels are decision trees, right? I'm just writing it as short DT. We know that decision trees are low bias and high variance models. High variance models. Okay. So we want a machine learning model, any machine learning model that we are employing, to be of the category low bias and low variance. Low bias and low variance. Now what is low bias? So it gets trained well on the training data. Okay, if the performance on the training data is good, we call that it has low bias. Also, if its performance is good on the unseen test data, we call it as having low variance. So generally the ideal model should be having low bias and low variance, but decision tree comes under the category of low bias and high variance. So just think that you are letting the decision tree to grow to its full depth. Full depth. So when I say full depth, each of the training records will be learnt instead of they will be remembered instead of learning, right? So decision tree, there will be each leaf node for one training record. Training record 1, training record 2, so on and so forth up to training record M. So once we achieve this, this is called as fully grown decision tree. Fully grown decision tree. So this will be of the category low bias and high variance. So if there is a slight change in the data that we are supplying to it, this will fail. This will not do well. This will not give the good predictions. So that's why we call it as having high variance. So decision trees, now you know that this is low bias and high variance category. Now we want to reduce this high variance to be low variance, right? Because anyway it is learning well on the training data, this bias will not get affected. But if the data is changed while training itself, complete decision tree structure would be different, right? So it will have to learn again from scratch. So again, you know how decision tree works, right? So it will try to find the root node based on Gini, impurity or entropy, and again it will try to find out some decision nodes based on the same criteria, Gini or entropy. So if there is a slight change in data, the working of decision tree will change rapidly. So how random forest evades that particular problem? So what it does, we know that we are doing row sampling and feature sampling with replacement. So any one decision tree will not have that much impact in changing the data set. So what we are doing indirectly is we are trying to reduce the variance by splitting the change in the data among multiple decision trees, thus reducing the impact of variance on each of these decision tree. So in the end, we will have the model, or the predictions will give us the model with low variance. Okay, so that's why random forest could give us low variance and low bias model. So that's it about this video, random forest, and I will have a separate video where I will cover the hyperparameters involved within random forest. Okay, so I will explain each and every parameter within the random forest in detail. Okay, so that's it for this video, guys. If you are liking the content, please give it a thumbs up. Please like the content, share it among your peers, and also if you haven't subscribed to my channel, please do subscribe. Till we see in the next video. Happy learning. Bye bye.